now we're going to take a look at some function operations. Remember, there were three ways we did function operations: tables, graphs, and algebraically. So remember what this open circle means. This is your composition notation. Remember what this means. This means your f of g of 3. So sometimes it's easier to rewrite it with the parenthesis notation. So the first thing you want to do is you want to find g of 3. So remember, 3 is your x value. So on your table, we want to know on function g, when x equals 3, what is the y value? So if you go to your table, when x equals 3, g of x is in my third column, my output is 2. So g of 3 is 2. So now I want to find f of 2. So again, when x equals 2, on function f, the y value is 1. So my answer is just going to be 1. Now there's a difference, remember, between this open circle and closed circle when we're dealing with function notation. This closed circle means multiplication. So what this actually means is I'm going to take g of 5 and multiply it by f of 5. So on my table, g of 5 is 1, f of 5 is 4. So 1 times 4 is 4. So again, just like in part A, you have the open circle. So this is my composition. With composition, you always work inside out. So g of 1. So when x equals 1, on function g, the output is 3. Now look on the outside. I have g of 3. So when x equals 3, the output for function g is a 2. So you have to be some function operations from a table. You also have function operations involving a graph. So again, you have g of f of 1. Remember, this is composition with the open circle, so I have g of f of 1. First thing you want to do is you want to find f of 1. So again, here is line f that I'm highlighting in yellow. So again, to find f of 1, remember 1 is the x value. On your line, you're made up of a whole bunch of points which have an x and a y value. So I want to find when x is equal to line on line f, which is right here. The y value at x equals 1 is a negative 1. So I know that f of 1 is negative 1. So now I want to find g of negative 1. Again, negative 1 on line g is right here. So when x is negative 1, the y value is 1. So my answer is 1. Again, it's another open circle, so I know it's composition, so I need to do f of 2. Remember, with composition, you always work inside out. So first I want to find f of 2. So on line f, when x is equal to 2, I want to find the point on the line which is right there, and the y value is 0. So f of 2 is 0. So now I want to find f of 0. So here's where x is equal to 0. The y value when x is 0 is negative 2. So this answer is going to be negative 2. So now we have g of negative 1, so now this is division. So I need to take g of negative 1 and divide it by f of negative 1. So g of negative 1, again, when x is negative 1, the y value on line g is 1, over f of negative 1. So on line f, when f is negative 1, the point on the graph is going to be negative 3. So the answer is going to be negative 1/3. So now when we do want to graph, now you have an absolute value function. Remember, the general shape of the absolute value function is the V shape. So remember, the negative sign on the front is a reflection over the x-axis. The plus 1 is going to shift it to the left 1. The minus 2 is going to shift it down 2. So again, if you remember, you have those key points on the parent function at negative 1, 0, 0, 1, 1. So I'm going to reflect each point. So negative 1, will go negative 1, 1, will go to negative 1, negative 1. And then I'm going to go to the left 1, and then I'm going to go down 2. 0, 0, I'm going to go to the left 1, down 2. And then 1, 1 will go to 1, negative 1. and then I'm going to go to the left 1 and down 2. So that's what my new graph looks like with the transformations. The domain is all real numbers. Range is going to go from negative infinity to negative 2. So the limit as x goes to infinity. Remember, this is your end behavior. Looking at the end behavior on the right-hand side. So this graph is going towards negative infinity. The limit as x goes to negative infinity, again, that's your end behavior. You're looking on, because it's negative, you're looking on the left-hand side of the graph. The left-hand side is also going towards negative infinity. And the limit as x approaches negative 1, again, you can just do a direct substitution into the equation. That's going to give you a negative 2.